So now I think you're ready to talk about some of the use cases and applications. So virtualization has proven to be reliable and versatile, and it's permeated much of the data center world in the last couple of decades. Yet organizations might continue to face important questions about suitable use cases and applications for virtualization deployment. Today, server virtualization can be applied across a vast spectrum of enterprise use cases, projects, as well as business objectives. Here's a few. Server consolidation. Consolidation is the quintessential use case for server virtualization. It's actually what put virtualization on the map. Consolidation is the process of translating physical workloads into VMs, and then migrating those VMs onto fewer physical servers. This reduces server count, mitigates the cost of server purchases and maintenance, frees space in the data center, as well as eases the power and cooling needs for IT. Virtualization enables IT to do more with less and save money at the same time. Consolidation might simply be an assumed use case for today, but it's still a primary driver for virtualization. Although server virtualization supports production environments and workloads, the flexibility and ease that virtualization brings to VM provisioning and deployment makes it really good for development and testing initiatives. So it's just a simple matter to provision a VM to test a new software build, experiment with VM configurations, optimizations, and integrations, getting multiple VMs to communicate, and validate workload recoveries as part of disaster recovery testing. See, these VMs are often temporary and can be removed when that testing is complete. Virtualization software also routinely includes an assortment of features and functionality that can enhance the reliability and availability of workloads running in VMs. As an example of that, live migration enables a VM to be moved between physical servers without stopping any workloads. VMs can be moved from troubled machines or systems scheduled for maintenance without any noticeable disruption. Functions such as prioritized VM restart ensure that the most important VMs, those with the critical workloads and services, are restarted before other VMs to streamline restarts after disruptions. Features such as snapshots can maintain recent VM copies, essentially protecting VMs and enabling rapid restarts with little, if any, data loss. Other availability features help multiple instances of the same workload share traffic and processing loads, maintaining workload availability should one VM fail. So virtualization has become a central element of maintenance and disaster plans. Centralization. Yeah, before server virtualization, the onus was on the IT staff to track applications and associated servers. Virtualization brings powerful tools that can discover, organize, track, and manage all the VMs running across the environment through a single pane of glass to provide IT admins with comprehensive views of the VM landscape, as well as any alerts or problems that might require attention. In addition, virtualization tools are highly suited to automation and orchestration technologies, enabling autonomous VM creation and management. So each VM runs its own unique OS. Virtualization has emerged as a convenient means for supporting multiple OSs in a single physical server, as well as servers across the entire data center environment. Organizations can run desired mixes of Windows, Linux, and other OSs on the same x86 server hardware that's completely abstracted by virtualization's hypervisor. In fact, there are very few enterprise workloads that can't function well in a VM. These would include legacy applications that depend on direct access to a specific server hardware device in order to function. And such concerns are rare and should disappear as legacy applications are inevitably revised and updated over time. Virtualization is accomplished through several proven techniques. The use of VMs, the use of para-virtualization, and the implementation of virtualization hosted by the OS. The VM model is the most popular and widely implemented approach to virtualization used by VMware and Microsoft. So this approach employs a hypervisor based on a virtual machine monitor, or VMM, and that's usually applied directly onto the computer's hardware. Right? Such hypervisors are typically dubbed Type 1 full virtualization or bare metal virtualization, and require no dedicated OS on the host computer. In fact, a bare metal hypervisor is often regarded as a virtualization OS in its own right. The hypervisor is responsible for abstracting and managing the host computer's resources, such as processes and memory, and then providing those abstracted resources to one or more VM instances. So each VM exists as a guest atop the hypervisor. Guest VMs are completely logically isolated from the hypervisor, as well as other VMs. Each VM requires its own OS, enabling organizations to employ a variety of OS versions on the same physical computer. Paravirtualization. Early bare metal hypervisors faced performance limitations, so paravirtualization emerged to address those early performance issues by modifying the host OS to recognize and interoperate with a hypervisor through commands called hypercalls. So once successfully modified, the virtualized computer could create and manage guest VMs. OSs installed in guest VMs could employ varied and unmodified OSs and unmodified applications. Now, the principal challenge of paravirtualization is the need for a host OS and the need to modify that host OS to support virtualization. Unmodified proprietary OSs like Microsoft Windows won't support a paravirtualized environment, and a paravirtualized hypervisor such as Xen requires support and drivers built into none other than the Linux kernel. Now, this poses considerable risk for OS updates and changes. An organization shifting from one OS to another might risk losing paravirtualization support, but the popularity of paravirtualization quickly waned as computer hardware evolved to support VMM-based virtualization directly, such as introducing virtualization extensions to the processor's command set. All right, so although it's most common to host a hypervisor directly on a computer's hardware, foregoing the need for a host OS, a hypervisor can also be installed atop an existing host OS to provide virtualization services for one or more VMs. That's why this is dubbed Type 2 or hosted virtualization, and it's employed by products such as Virtuoso and Solaris Zones. So the Type 2 hypervisor enables each VM to share the underlying host OS kernel along with common binaries and libraries, whereas Type 1 hypervisors do not allow such sharing. Hosted virtualization potentially makes guest VMs far more resource efficient because VMs share a common OS. The OS need not be duplicated for every VM. So consequently, hosted virtualization can potentially support hundreds, even thousands of VM instances on the same system. However, the common OS offers a single vector for failure or attack. So if the host OS is compromised, all the VMs running atop the hypervisor are potentially compromised too. The efficiency of hosted VMs has spawned the development of containers. So the basic concept of containers is actually identical to hosted virtualization, where a hypervisor is installed atop a host OS, and virtual instances all share the same OS. But the hypervisor layer, for example, Docker, is tailored specifically for high volumes of small, efficient VMs intended to share common components such as binaries and libraries. So containers have found significant growth with microservice-based software deployments. This is where agile, highly scalable components are deployed and removed from the environment quite quickly. So virtualization brings powerful capabilities to enterprise IT, but virtualization requires an additional software layer that demands careful and considered management, especially in the areas of VM deployment and migration. A VM can be created on demand. Manually constructing the VM by provisioning resources and setting an array of configuration items, then installing the OS and application. Although a manual process can work fine for ad hoc testing or specialized use cases, such as software evaluation, deployment can be vastly accelerated using templates. Now, these stipulate the resources, configuration, and contents of a desired VM. A template essentially defines the VM, right? And then it can automatically be built quickly, accurately, and then duplicated as needed. Major hypervisors and associated management tools support the use of templates, including Hyper-V and vSphere. So templates are important in enterprise computing environments. They bring consistency and predictability to VM creation, ensuring resources that are optimally provisioned, security that is correctly configured, such as adding shielded VMs in Hyper-V. All contents added to the VM, such as OSs, are properly licensed, and the VM is deployed to suitable servers to observe load balancing and other factors in the data center. So templates not only streamline IT's efforts and enhance workload performance, but also reflect the organization's business policies and strengthen compliance requirements. Tools such as Microsoft Systems Center Virtual Machine Manager, Packer, and Power CLI can help create and deploy templates. Migration is the second vital aspect of virtualization process and practice. Different hypervisors can offer different feature sets and are 100% interoperable. See, an organization might opt to use multiple hypervisors, but moving an existing VM from one hypervisor to another requires a means to migrate VMs created for one hypervisor in order to function on another hypervisor instead. So consider, if you will, a migration from Hyper-V over to VMware. Now, this is where tools such as VMware vCenter Converter can help migrate VMs en masse. That's a lot, all at once. All right. Migrations typically involve a consideration of current VM inventory. And these should detail the number of VMs, destination system capacity, and dependencies. Admins can then select source VMs, set destination VMs, including any destination folders, install any agents needed for the conversion, set migration options such as the VM format, and submit the migration job for execution. Right, so it's often possible to set migration schedules, enabling admins to set desired migration times and groups so related VMs can be moved in the best order at a time when effects are minimized. Managing virtualization across an enterprise requires a combination of clear policies, conscientious planning, and capable tools. Virtualization management can usually be clarified through a series of common best practices that emphasize the role of infrastructure as well as the business. You got to have a plan. Don't adopt virtualization for its own sake. Server virtualization offers some significant benefits, but there are also costs and complexities to consider. An organization planning to adopt virtualization for the very first time should have a clear understanding of why and where the technology fits in their business plan. Now, similarly, organizations that already virtualize parts of the environment should understand why and how expanding the role of virtualization is going to benefit the business. See, the answer might be obvious, as a server consolidation project to save money, or a vehicle to support active software development projects outside of the regular production environment. But you got to remember, regardless of the drivers, have a plan before going into a virtualization initiative. In other words, do the research. Assess the hardware. So you got to get a sense of scope, right? Virtualization software, both hypervisors and management tools, must be purchased and maintained regularly. Understanding the number of systems as well as the applications that are involved that must be virtualized and investigate the infrastructure to verify that the hardware should support virtualization, all of this stuff. Almost all hardware is going to be suited for virtualization, but you got to perform the due diligence up front to avoid discovering an incompatibility or inadequate hardware during an installation. Now, any new virtualization rollout is typically preceded by a period of testing and experimentation, especially when the technology is new to the organization and IT team. So IT teams should have a thorough working knowledge of a virtualization platform before it's deployed and used in a production setting. Even when virtualization is already present, the move to virtualize new workloads, especially mission-critical workloads, should involve detailed proof-of-principle projects to learn the tools and validate the process. But smaller organizations can turn to service providers and consultants for help if necessary. Now, virtualization should be deployed and used according to the needs of the business. I think I've repeated that a few times, but maybe not enough. Because they also have to include a careful consideration of security, regulatory compliance, business continuance, disaster recovery, and VM life cycles, provisioning, and later recovering resources. IT management tools should support virtualization and map appropriately against all those business considerations. Organizations that are new to server virtualization should follow a period of testing and experimentation with small, non-critical virtualization deployments, such as test and development servers. Seek the small and quick wins to gain experience, learn troubleshooting, and demonstrate the value of virtualization while minimizing risk. So then once a body of expertise is available, the organization can plan and execute a more complex virtualization project and grow from there. So as the organization embraces server virtualization, it's then appropriate to create and adopt guidelines around VM provisioning, monitoring, and life cycles. Computing resources cost money, and guidelines can help codify the processes and practices that enable an organization to manage those costs, avoid resource waste by preventing over-provisioning and VM sprawl, and maintain consistent behaviors that tie back to security and compliance issues. Guidelines should be periodically reviewed and updated over time. Virtualization management tools usually aren't the first consideration in an organization's virtualization strategy. See, virtualization platforms typically include basic tools, and it's a good practice to get comfortable with those tools in the early stages of virtualization adoption. Now, eventually, the organizations might find benefit in adopting a more comprehensive and powerful tools suite that support large and sophisticated virtualization environments. But by then, the organization and IT staff will have a much clearer picture of the features, benefits, and functionality required from such a tool, why those features are needed, and how these features will benefit the organization. Server virtualization management tools are selected based on a wide range of criteria, including licensing costs, cross-platform compatibility, supporting multiple hypervisors from multiple vendors, support for templates and automation, direct control over VMs and storage, and even the potential for self-service and chargebacks. And this would all enable other departments or users to provision VMs and receive billing if desired. Organizations can choose from many server virtualization monitoring tools that vary in features, complexity, compatibility, and cost. Virtualization vendors typically provide tools intended for the vendor-specific hypervisors. So, for example, Microsoft System Center supports Hyper-V, while vCenter Server is suited for VMware hypervisors. But organizations can also opt for third-party tools, including ManageEngine Applications Manager, SolarWinds Virtualization Manager, and Veeam. Ultimately, virtualization lends itself to automation and orchestration techniques that can speed common provisioning and management tasks, while ensuring consistent execution, minimizing errors, mitigating security risks, and bolstering compliance. Generally, tools support automation, but it takes human experience and insight to codify established practices and processes into suitable automation. Now, there are numerous virtualization offerings in the current marketplace, but the choice of vendors and products often depends heavily on virtualization goals and established IT infrastructures. Organizations that need bare metal Type 1 hypervisors for production workloads can typically select from VMware, vSphere, Microsoft Hyper-V, Citrix Hypervisor, IBM Red Hat Enterprise Virtualization, or RHEV, and Oracle VM Server for x86. So VMware dominates the current virtualization landscape for its rich feature set and versatility. Microsoft Hyper-V is a common choice for organizations that are already standardized on Microsoft Windows Server platforms. RHEV is commonly employed in Linux environments. Hosted Type 2 hypervisors are also commonplace in test and development environments, as well as multi-platform endpoints, such as PCs that need to run on Windows and Mac applications. Now, popular offerings include VMware Workstation, VMware Fusion, VMware Horizon 7, Oracle VM VirtualBox, and Parallels Desktop. VMware's multiple offerings provide general-purpose virtualization, supporting Windows and Linux OSs and applications on Mac hardware, as well as the deployment of virtual desktop infrastructure across the enterprise. Oracle's product is also general-purpose, supporting multiple OSs on a single desktop system. Parallels hypervisors support non-Mac OSs on Mac hardware. Hypervisors can vary dramatically in features and functionality. So, for example, when comparing vSphere and Hyper-V, decision makers typically consider issues such as the way both hypervisors manage scalability, the total number of processors and clusters supported by the hypervisor, dynamic memory management, cost, and licensing issues, as well as the availability and diversity of virtualization management tools. But see, some products are also designed for advanced mission-specific tasks. So in comparing vSphere ESXi to Nutanix, Nutanix AHV brings hyperconverged infrastructure, or HCI, software-defined storage, and its Prism management platform to enterprise virtualization. However, AHV is intended for HCI only. So organizations that need more general-purpose virtualization and tools might turn to the more mature VMware platform instead. Organizations can also choose between Xen, commercially called Citrix Hypervisor, and Linux KVM hypervisors. See, both can run multiple OSs simultaneously, providing network flexibility. But the decision often depends on the underlying infrastructure and any cloud interest. Today, Amazon, for instance, is reducing support for Xen and opting for KVM, and this can influence the choice of hypervisor for organizations worried about the integration of virtualization software with any prospective cloud provider. Now, ultimately, the choice of any hypervisor should only be made after an extended period of evaluation, testing, and experimentation. IT and business leaders should have a clear understanding of the compatibilities, performance, and technical nuances of a preferred hypervisor, as well as a thorough picture of the cost and license implications of the hypervisor and management tools. Say, you know what? We're going to wrap it up right now. That's all about server virtualization. So, stay tuned for the next video because we've got more in store.